Hello, I am Shravan Kumar Korapati. First of all, thank you for providing me the opportunity to do the interview with memory machines. This is my GitHub location for the assignment. As you can see, this is the high level architecture diagram with four components. Basically, it's the client which makes requests in JSON or text format. So the four critical components are the Cloud Run API, which accepts requests and returns 202 immediately. And then we have Cloud Pub Sub for message queuing with guaranteed delivery. A Cloud Run worker is next coming that process messages asynchronously, and Cloud Firestore for storage with strict multi-tenant isolation. I chose Cloud Run because it's serverless and auto scales from 0 to 10 instances. PubSub because it guarantees at least once delivery with automatic retry, and Firestore because it supports subcollection, which gives me true physical tenant isolation, not just logical filtering. Let me walk through the Google Cloud console to begin with the topic which I have created, which is log ingestion. So here the metrics could be seen like the published messages count. So I did testing for a few of the calls. I indeed did one load testing as well. So those calls can be reflected over here. Then I have the Cloud Run worker process where I'm logging the requests as well. So you can see the messages that have been received and processed on worker side. And at database level, you can see I have a collection called tenants, and each tenant has a separate document. For example, if I go to tenant 0, I have another sub collection which is process logs. This is like a physical separation. And then if I go to another log which is at each detail information on based on the call. So these are the number of calls that I have done. So one of the call I will go through. So this is one sample call where I have passed on a JSON request for this particular tenant. So this is the way I structured the information. So why I chose this approach was like the assignment requires strict tenant isolation. I could have used a single all logs collection with a tenant id field, but that only provides logical separation. But when you have to filter on every query, there is risk of bugs exposing data across the tenants. With my approach, using sub collections, each tenant is physically isolated. It's impossible to accidentally query another tenant's data because they are in separate document paths. This is more secure, performs better because queries are scoped to one tenant and makes tenant management easier. Let me go to my terminal to show one demo request. So this is a sample request that I am placing to my live link on GCP. So this is a JSON request for the demo tenant 1. I am trying to send the request. So this is the log ID and this is the text sample that I am trying to process. So it responded to me saying that the request has been accepted and the message has been queued for processing. So what will happen is it will go through the flow and ultimately from the pub sub it lands up with worker and then it moves on to Firestore. So let me see on the worker log if the log has reflected over here. So around 17:43 we placed the request. So you can see that the message has been received over here. You can see the log information of demo tenant 1, and it has been successfully processed and saved to Firestore. So now let me go to the Firestore and query the DB. So this is demo tenant 1. Let me go to process logs, demo log 1. So this was the message that I passed on. So you can see all the information that is being stored at this document level. I also did load testing as part of my personal analysis, and even the load testing was successful. So I try to have a kind of Python script ready, which will have 1,000 requests, and I place the load to our live URL. So I try to process all the 1,000 requests. So all of them were successful with 202, and all of them were processed. The time elapsed was around 28 seconds, with requests per second around 35. Average response time was around 27 milliseconds. So even on the load testing part, this particular project was successful. So thank you for once again for providing me the opportunity. Hope you like my project presentation as well.